In this second example, I have two objects. I have a piece of brass inside of some water, and they've given me some of the information, and I've already organized it for us. I know the C value for water is 1.48 times 10 to the 3 joules per kilogram degrees Celsius, and I know the C value for brass. It's given in the equation. But you'll notice they've also told me the volume of water is 400 mils, but I know the density of water is 1 gram per milliliter, which means 400 mils is 400 grams. But this is the problem. This is in grams and this is in kilograms, which means I need to convert it. I need to divide by 1,000 or move it 3 decimal places. And I have to do that for both of these because they need to match whatever is in the C value. Then I'm going to think about my change in temperature. It tells me the water starts at 27.7 and ends at 28. So that's pretty straightforward. It ends at 28 and it starts at 27.7, which means there's a very small temperature change of 0.3 degrees. When I look at my brass, I only know one of these numbers. I know it ends up at 28 because the combination ends up at 28 degrees. I don't know the original temperature, but that is what I'm trying to find. Now I have my information organized. I can say that the Q gained is equal to the Q lost, but I have to make it equal to the negative Q lost because numerically, whatever this lost by the one is gained by the other, but one will be a negative number and one will be a positive number, which is what this negative is going to fix. So I'm going to put my MC delta T values for my water on one side and for my brass on the other. So I know the mass, I have that, right? I know the mass of the water. I know the C value of the water. I can put that in. I know the change in the temperature of the water. Figured that out already. I know the mass of my brass. I know the C value of my brass. What I don't know is all of my numbers for my change in temperature. So I'm just going to write it out like we wrote it. There we go, 28 minus T1. Now this side I can do, right? I can do this side no problems because I can just put that right in my calculator and find the value. So I'm going to say 0.4 times my specific heat capacity times my change in temperature, and I get a number. So I'm going to simplify this side completely. This side, I can simplify the start at least, right? So I can say multiply those and I'm going to get negative 57. And then I have this bracket, but we learned how to do this in grade 10 math. Remember, when you do this, you just need to multiply everything in the bracket by the number outside, right? So I'm going to go 57 times, or negative 57 times my 28 first. This side I'm going to leave alone for a second. Oops. Weird things are happening. Sorry. I clicked on something weird. So I get negative 1596. Negative 57 times this will give me positive 57 T. That's supposed to be a 7 T1. So now I can move this over. This is going to come over and become positive. So they will add, right? When it goes to the other side, it becomes positive. So I end up with 2097.6 is equal to 57 T1. Then I can just divide out my 57. So I'll divide by my 57 and get my number. And I get 36.8 degrees Celsius. Now I can only take this to 2 sig figs, so it's actually 37 degrees Celsius. And I have to think about, is this a sensible number? Yes, it is, right? Because it's higher than my water number originally, and it is possible to get a piece of brass to that temperature.